So my problem is two basketballs are moving towards each other. After they collide, they move apart. Basketball number 2 has a velocity of 7 meters per second at 345 degrees. What is the final velocity of basketball number 1? So the diagram shows us the initial velocities and angle measures of the two basketballs. So note that the first basketball has an initial velocity of 9 meters per second at 310 degrees, and its mass is 5 kilograms. And the second basketball has a mass of 6 kilograms, and it's going 10.5 meters per second at 40 degrees. Since the initial velocities and angle measures are given to us, we could figure out the vertical and horizontal components. So let's say we were to make this a triangle, and we know that this angle measure is 310 degrees for the first basketball. We could find out this and this component. So we could do the cosine of 310 degrees times its mass, which is 5 kilograms, times its initial velocity, 9 meters per second, which would equal 28.925 kilogram meters per second. So we could plug that number into here. And then we could solve for the vertical component. So we would just do sine of 310 degrees times 5 kilograms times the initial 9 meters per second, which would give us negative 34.472 kilogram meter per second. And then for the second basketball, we would just do the same thing. The triangle will look like this. This would be 40 degrees. And we can figure out the vertical and horizontal components. So to find the horizontal, we would do cosine of 40 times its mass, 6 kilograms, times its velocity, 10.5 meters per second. We would get 48.201 kilogram meters per second. And then same for the vertical, sine of 40 times the mass, 6 kilograms, times the velocity. We would get 40.496 kilogram meters per second. So we could plug those two numbers in over here. And to get the totals, we would just add them up. So this side would equal 6.024 kilogram meters per second, and then we would get 77.126 kilogram meters per second. So we know that the initial and final components have to be the same, so we could plug these numbers in down here. And the problem gives us the final velocity and angle measure of the second basketball. So we could find its horizontal and vertical components. So cosine of 345 degrees times, we know it's 6 kilograms, and its velocity is 7 meters per second. And that gives us 40.569 kilogram meters per second. And then we would do the opposite, sine of 345 degrees, 6 kilograms, 7 meters per second, and that gives us negative 10.870 kilogram meters per second. So we could plug those two values in. And we know that these two values would have to add up to that. So simple addition, subtraction. So using the horizontal and vertical components of the first basketball, we can make a triangle. So we know that it's horizontally, positively going 306.557, vertically going 16.894, and using the Pythagorean theorem, we can calculate the hypotenuse, which we get 40.272, and these are all kilogram meters per second. So to find the final velocity of the first basketball, we would do the hypotenuse, 40.272 kilogram meters per second, divided by its mass, which is 5 kilograms. So the kilograms cancel out, and you get 8.054 meters per second. So to find the angle measure, you would plug in the horizontal and vertical components. So you would do the tan inverse of opposite over adjacent, so 16.894 over 36.557, and that comes out to be 24.803 degrees. So we know that the final velocity and angle measure of the first basketball is 8.054 meters per second at an angle measure of 24.803 degrees.